Chapter 3, Section 2, Question 40, more or less 40 anyway. Determine the probability that at least 2 people in a room of 8 people share the same birthday, ignoring leap years and assuming each birthday is equally likely, by answering the following questions. A. Compute the probability that 8 people have different birthdays. B. The complement of 8 people have different birthdays is at least 2 share a birthday. Alright, if you notice from the way the question began, this is really what we're looking for. What's the probability at least 2 of the 8 share a birthday? And they're helping us out here by telling us that 8 people have different birthdays is the complement. Okay? So let's work on part A. Compute the probability that 8 people have different birthdays. Alright. This is really just a fairly straightforward, without replacement question, but the trick to it, or the difficulty, is it's worded enough differently that it's not obvious that's the case. So let's think about it. So we're going to do this one person at a time. So first, you pick the first person of the 8. What's the probability that person's birthday doesn't match the birthday of anyone before? Well, there's no one before to match, right? So out of the 365 birthdays in a year, it really doesn't matter which one you pick. It's not going to match anybody. All right? Second person you pick. Well, if they're not going to match anyone before, then the second person can be any day except the day of the first person, right? So 364 out of the 365 days in a year will work. Third person can't match either one of the first 2, so that just eliminates 2 days, so we're down to 363 days out of the 365 days in the year. And this pattern just continues for all 8 people. Alright, so 360 over 365. Let's see how many people is that. 1, 2, 3, 4, 5, 6, so I need 2 more. So 359 over 365 and 358 over 365. That equals what? Alright, well, let's break the calculators out and see what that comes. Okay, I get 0.925665. And I think I cut it off, but I think the question asked to round to 3 decimal places, if I'm remembering that right, so this would be 0.926. So that's part A. Part B then says the complement of 8 people have different birthdays is at least 2 share a birthday. Use this information to compute the probability that at least 2 people out of 8 share the same birthday. Remember, the probability of complement is 1 minus the probability of, if you will, the original. Alright? So this is 1 minus 0.926 equals 0.074. And that is it for this one.